Okay, so now we're going to talk about domain specificity. All right. And again, this domain specificity, it deals with the range of questions for which a device provides answers, right? So it's the range of inputs for which it computes analyses. So if you had like, for example, if you had a light detector that only responded to light, right? Then whatever the light rate wavelength, the range of wavelengths uh, that that the detector can detect or can use, right? That would be the domain uh, of inputs or the range of inputs that could be used, right? And so basically, there's some proximal stimulus that turns on the module. So for example, if there may or may not be, but if there was like a face module that processes faces and only faces, then it would probably be turned on whenever it sees a face, right? However, it probably would also be turned on by things that kind of look like faces, right? So we all hopefully know that some cars look like faces. They have facial likeness to it. So this yellow car kind of looks like a happy face, whereas this Toyota doesn't so much look like a face. Um, so the point of this is that it's not really clear what turns on a module, right? So it could be for a face processing, it could be that obviously faces would have to turn it on, but also other things might turn it on too. We just don't know. It's not really clear what that range uh, or domain specificity is. All right. Another thing that we talk about is called information encapsulation. So this involves two things. This involves a restriction on the flow of information into a mechanism, right? And so that, we talked about the Miller-Lyer illusion, right? So your background beliefs don't influence how you see this. Uh, Even though you know it's a certain way, you still can't unsee you can't see what you think, I guess is what I would say. The McGurk effect is also another example of information encapsulation. So the McGurk effect is when so if you see somebody saying what ba with their lips, right? Ba, and you can tell that even if you couldn't hear ba, you probably would get a sense that I might be saying ba, right? Well, okay, so you see ba, but then there's audio that just says ga. So I'm like ga, right? I'm like ga, so to speak, right? And what your brain perceives is fa. So it's kind of a mixture, I guess, of the two. And the reason I put this up is because people who've done this, who've seen this, the McGurk effect will tell you that people who've been studying the McGurk effect for years, they're still tricked by it. I mean, uh, they hear fa, even though they really hear ga and see ba, but their brain perceives it as fa. And they know about this effect, but they still can't, um, undo or counter this sort of illusion or error. Information encapsulation also involves not just the inflow of information into a mechanism, but it also involves the restriction of flow of information out of a mechanism. So this means is that there's no access to the raw information that was used to create the output. It's sort of like a module is kind of like a black box, right? There's input that goes into the black box. What happens? We don't really know. And then there's output, right? So the idea is we don't really know what the input I guess we do. Yeah, we don't know the input that went into it. So it's related to domain specificity, right? But we also don't really know what happened inside the module. It's not quite clear. Another thing is mandatoriness. So mandatory application, right? So this is synonymous or equivalent to automaticity, right? So the fact that I'm talking right now is an automatic skill. The fact that I can read is an automatic skill, right? It doesn't mean it's innate, but it's automatic at some point. Walking is an automatic skill for many people from, once you grow up, right? And one thing that demonstrates mandatoriness is the Stroop effect. And I should have animated this, but so the Stroop effect is like, what color are these letters, right? And most people can say red pretty quickly. But if I were to show you red, or sorry, if I was to show you the word blue, but in purple letters, and your task was to say the color of the ink of the word, people would have difficulty doing this task. It would take them a little bit longer to say purple. And the reason is because our skill of reading is so automatic, right? That uh, it sort of interferes with our ability to name the ink of the word. Another example is sentence comprehension that shows some degree of mandatoriness. So there's some garden path sentences, which we're going to talk about more late in a little bit. But, for example, the horse raced past the barn fell. Now, again, if you're a normal person, this doesn't make any sense, at least not to me, it didn't. And really what it's saying is the way that it's totally grammatical sentence. The syntactic structure is totally fine. Uh, but it doesn't make any sense. And what it's really trying to say is the correct interpretation is the horse that was raced past the barn fell, right? So the horse fell, not the horse raced. Uh, and then another one is, the old man, the boat, right? So is it the old man, the boat? What? That doesn't make any sense. No, it's the old people, right? The old people, man, whatever that, I don't know what that means, but they do something to the boat. Okay, so man is a verb here. And the idea is that the reason why you have trouble with these sentences is because you are trying to figure out what the syntactic structure is, and you've sort of mandatorily assigned uh, the syntactic structure, right? So as you read the old man, the boat, right, you probably went the old man and thought, okay, that's a noun phrase. But then when you saw the boat, you're like, well, that doesn't make any sense. And so, but the point is that you're automatically assigning the old man to be the noun phrase, right? So you're figuring out what the syntactic structure, the grammatical structure of the sentence is. And sometimes you can get into that can get you into trouble if it's a garden path sentence because yeah, the syntactic structure is a little awkward. And we're going to talk about that more in a little bit. Okay, so I guess I just would mention one more thing, which is we've already kind of seen this modularity thing going on, right? So if the 2D, remember Mars levels, this is the algorithmic level. So if the 2D image is the input, right? Maybe this is the transducer that gives you this sort of primal sketch representation. And then that representation is input into these other submodules. Maybe this, I don't remember what this is, but this is like the output maybe from some module that encodes things about not depth, but something else, right? And then this is like the depth module. And then I don't know what this is, but the point is that these are all outputs from very specific modules that receive this primal sketch as the input. And then that yields this sort of 3D image at the end. Okay, and so next video we'll talk more about, again, more about modularity.